Welcome to our class on estimation and sampling. So estimation and sampling is important, but before we go any further, we need to understand a few parameters that are involved under estimation and sampling. To start with, there are symbols that we need to be conversant with. For instance, we have what we call Q hat. This is a complement of the proportion P hat. So these ones must add up to 100. If P hat is 10%, Q hat must be 90%. We have what we call sample mean, which is simply calculating the average summation of x over n. Sample proportion, which is our P hat, 1 minus alpha, which is our confidence level. Confidence level can also be written as CL. Confidence interval, CI, is given by a formula which we discuss. So we have what we call the lower class limit and the upper class limit. These are lower bounds and upper bounds. We have the margin of error. The sample size is denoted by the letter N. The null hypothesis test of significance, NHTS. The binomial proportion P. The sample standard deviation is simply denoted by S. The sampling distribution of the mean, STM. Standard error of the mean, SEM. Standard error of the proportion is SEP, and the upper class interval limit, alpha, the mu, which is the expected value or population mean, and the standard deviation parameter. Now, we need to understand the following issues when we're discussing estimation. So estimation has the following formulas. Whenever we're asked to find the confidence interval, we are being asked to find an estimate. It's given by x bar plus minus the error, which will give us a lower class limit, comma, the upper class limit. These ones can also be called the lower bound, comma, upper bound. So the confidence interval is simply given by mean plus or minus z standard deviation over the square root of n. We always use the z whenever our samples are greater than 30. This is when you're dealing with a sample. But when you're dealing with a proportion, our formula becomes z pq over n square root. Now, we need to know the confidence intervals based on the confidence levels, significance levels, our alpha, and our z. Now, we have 99%, 98%, 95%, and 90%. So the difference from 100 is called a level of significance level. Here we have 1%, we have 2%, we have 5%, and we have 10%. Our alpha level is the difference, is when we divide this by 100, which is 0.01. Here we're going to have 0.02, and here we're going to have 0.05. And finally 0.10. Now, when you divide this by 2, and subtract it from 1, you need to read it from inside the table. So 0.01 divided by 2 is going to be 0.005. When you subtract it from 1, what are you getting? Well, let me do this one here. Okay, so 0.05 divided by 2, you get 0.025. When subtracted from 1, you get 0.975. Is that clear how I'm getting this? Divide this by 2 and subtract from 1, you get 0.975. Then you check it from inside the table. The Z table, when you go to the Z table, but the table is here, this is called the Z table. So the reading for any arbitrary number like 1.23 or 1.22 is 0.888. But if I ask you using this probability to give me the Z, it would be 1.2322. So 1.95, the reading is 1.96, the reading is 0.9750. But if I ask you to give me the Z for 0.9750, you're going to get 1.96. So this is the Z. We divided 0.05 divided by 2, we get 0.025. When subtracted from 1, we get 0.750. It's a probability, which is here. So when I add what is this side and that side, I'm going to get a 1.96. This is where the 1.96 here is coming from. The Z for 95%, 1.96. For 98%, can you tell me what we do? We divide this by 2. What are we getting? 0.01. Then we subtract the 0.01 from 1. What are we getting?
0.99.
0.9900. Then we check inside the table corresponding 0.9900. Which one is corresponding? So which one is closest? Sometimes may not be the exact one, but the closest one is here. 2.33. So this is Z is equal to 2.33. So here again, you divide this by 2, which is 0.005. And you subtract it from 1. Check it inside the table, you're going to find our Z as 2.58. Similarly here, our Z will be 1.64. Actually, 64 and 65 will be equidistant, so we pick both of them, 645. So ideally, I'm just teaching you how to get these figures. Any questions at this point? So in a nutshell, the Z for 99% is 2.58. The Z for 98% is 2.33. The Z for 95% is 1.96, and the Z for 90% is 1.645. This is called the confidence level. When you subtract from 100, it's called the significance level. So 99 is the same as 1%, which is 0.01. And the Z is 2.58. 98 is the same as 2% or 0.02, which is 2.33. By the way, this is just by dividing this by 100. So 5% divided by 100, our alpha is what? 0.05. And our level of confidence level is what? 95%. So 90% plus 10%, 0.10. All right. So can you remember quickly what is, we have 99%, then what? 98, then
95.
then
90.
the level of significance, we have what? The difference from 100.
1%.
1%.
1%. 2%. 5% and 10%.
Great. And the alpha, when we divide this by 100, what do we get?
0.01.
0.01. Good. People make a mistake here and here. And here. Now, what is our Z?
0.10.
The 2/3.
2.58. 2.33.
Mhm.
1.96. 1.645.
Now, suppose we had 97%. What is the zinc plus level for 97%?
3%, sorry.
3%. Good. Then alpha.
0.03.
Just divide by 100, 0.03. And to read here, what do we do? Is 1 minus what? Alpha over 2. 1 minus 0.03 divided by 2. What do we get?
1 minus 0.015.
Yes. What do we get?
0.985.
0.985. And you read this one inside the table. When you go inside the table, we look for 0. What? Yeah, 9850. So check inside here. Which one is close to 0.985? This one here, right? So what is the reading for this?
2.17.
2.17, correct. So this is 2.17. That's how these figures are figured out. Then we have the formula for confidence interval. What is the formula for confidence interval? Mean plus minus Z standard deviation over square root of n. All right. If you're dealing with a proportion, confidence interval is what? P plus minus Z PQ over n. All right. So I'll try 2 questions. Find the confidence interval if our mean is 10, sample size is 36, our standard deviation is 12, and our alpha is 0.05. Then our B, find the confidence interval if our P 20%, our N is 100, and our confidence acceptance level is 1%. All right, so I'll try these 2. So part A, we're using formula 1. Part B, we're using formula 2. So confidence interval part A, what is our mean? Our mean is 10 for x bar. And what is our Z? At 0.05, 1.96. And our standard deviation is 12. Our N is 36. So we have 10 plus minus what? 1.96 times 2. This is 36, which is 6 into 12 is 2. So here we're going to have 10 plus minus 3.92. So when you subtract 10 minus 6, what are we getting? 6.08, is it? And when we add, we get 13.92. We say we are at 95% confident that the true mean will lie between 6.02 and 13.92. You always comment in terms of the confidence interval, confidence level. At B, we're using formula 2, since we're given the proportion. Here, where there's P, we put 0.2. We know that P and Q are related. If P is 0.2, then Q will be 0.8. Plus minus Z. What is our Z at 1%? 2.58. And our P, 0.2. And our Q, 0.8. And our sample size N is what? 100. So here we're going to have 0.2 plus minus 2.58. So here, what is 0.2 times 0.8 divided by 100? Then you square root it. What are you getting?
I'm getting 0.04.
0.04. When you try this one by this, what are you getting?
0.1032.
When you subtract this minus that, what are you getting?
0.0968.
Okay. 0.0968. Then when you add
68. 0.3032.
3032. Then you comment in terms of the confidence interval. We are 99% confident that the true proportion will lie between 9.68% and 30.32%. That is how we do it. Any question? Right. So now we have a sample. Sampling has the following formula: Z squared variance over the error. Error comes in terms of the weight within. So using the proportion is PQ over the level of precision. So the examiner will ask you, find the sample size given A alpha is 0.02. Standard deviation would be 4. Error will be within plus or minus 2. Will be given our level of significance, which is 1%, and our P is 20%, and our error is within plus or minus 4%. So using the formula that we just discussed right now, we're going to say n over a is z squared, deviation squared, error squared. So what's the answer there? Daphne, you have a question?
No, I thought you were talking, so I wanted to ask you to check your mic because I couldn't get anything.
Okay, but you can hear me. So here I'm just
Yes,
substituting
I
z squared 2.33. Our standard deviation is 4, and within our error is 2. Okay, so when you calculate this, what are you getting? What are you getting?
5.4289 times 16 over 4.
Mhm. What are you getting?
21.7156.
716. In the
56.
event that 56. In the event that you are given, instead of standard deviation 4, you're given variance of 4. The only difference is that don't square the 4 here. You simply have what's already squared in terms of variance. You simply going to have 2.33 squared times 4 over 2 squared. So this and that cancels. So we're going to have 5.1. Something. So you need to also be careful what you're given. This one part A. Is that clear? You're given a variance here. Don't square it here because it's already squared as variance. Get the difference?
Yes.
Then the second one here, Q over E. So here we have our Z as 2.58 equals 1% here. And our P is 20%, so 0.2. And our Q is 0.8 over our error is what? Within 4. So since the percentage, put 0.04. Just within 4, so that the percentage is just put 4 squared. What are we getting here? What are we getting? Right there. Yes, that's me. What are you getting?
Just a minute. We have 6.6564 times 0.16. Just a minute. We have 665.64.
665.64. Okay. Now, here is how the questions come. I've sent you work on the group. So here is how the questions would come. I want you to now help me identify what is being asked for. We have a question here. A politician claims that more than 50% of the females in a presidential election vote. A sample of 500 registered voters showed that 275 of them voted last presidential election. Construct a 9% confidence interval for the true proportion of female voters, 3 marks. Test the claim at 5% and can the confidence interval be used to answer part 1 to explain. Okay, now for proportions, if you're not given, you need to understand one key thing. It's a little bit now becoming complex, because there are a few things that you need to know. So here, what are we given? In this question, what are we given? We're given number 1, a politician claims that more than 50% of the females can vote in presidential elections. A sample of 500 female registered voters showed that 275 of them voted. So there's a big population, which is 500, and a small population, which is 275. So when you divide the bigger population into the small population, you get a proportion, P. So what is 275 divided by 500? What do we get?
0.55.
0.55. So this is our P. So meaning, what is our Q? Difference from 100 is 0.45.
1.45.
So confidence interval will be P plus minus Z PQ over capital N squared. So here we found 0.55. We're finding a 95% confidence interval. At 95%, our Z is 1.96. 0.55 times 0.45 divided by the big population of 500. Is that clear? Then the rest, you know what to do. Now, I must make mention to say, if you have a confidence interval, of course, I'll teach you under hypothesis testing, but we are what we call a significance test. Whenever I have a positive number here, comma, a negative comma, a positive number, this means that there's what? No significant difference between the means. But if you have both negatives and both positives, means there is a significant difference between the two means that you're testing. So a significance in the differences exists if they're both positives or they're both negatives. All right. So also what else you need to know from the formulas I gave you is that if you're given a confidence interval of say 10 to 30, the mean is the difference between the two divided by 2. The lower bound plus the upper bound divided by 2. 10 plus 30, which is 40 divided by 2. Our mean is 20. Then our error is the difference between the two, lower bound minus upper bound, or upper bound minus lower bound. Since it's an error, I get plus minus. So 10 minus what? 30, which is 20 divided by 2. Get our error is what? N. So if you're given a sample size of, for instance, 100, if you're given our alpha as 0.05, you're asked to find the standard deviation. So we know that our N is equal to Z squared, standard deviation squared over error squared. Our N has been given as 100. Our Z from the 0.05 is 1.96 squared. Our standard deviation is what we don't know. Our error, we found 10. So when you cross multiply, 10 squared times 100 is what? 10,000. You divide by 1.96, we get the standard deviation, the variance, and when you square root it to give you the standard deviation. So we just cross multiply here. So here we're going to have 1.96 squared over variance times 10 squared 100. So we divide 1.96 squared on both sides. The answer we get is your variance, and you divide it by what? By 1 point. You square root it to get the standard deviation. So find a 95% confidence interval estimating the height of 1546 male students at a university, taking a sample of 100. The mean is 67.45 and standard deviation is 2.93. So we are being asked to find a 95% confidence interval. So 95% confidence interval is mean plus minus Z. Our mean is what? 67.45 plus minus the Z is what? 1.96. Then Our standard deviation is what? 2.93 over n is what? 100. So we can find and comment on that. Example number 3, a sample of 100 votes chosen at random from a district indicates that 55% were in favor of a candidate. So P is 0.55, meaning Q is 0.45. Our N is 100. Find the 99% confidence interval. So 99, we have our Z as 2.58. We need to find this. So this will be your homework. Then here, in a sample of 400 adults, 600 teenagers, a program showed that 100 of the adults and 300 of the teenagers indicate they like it. Find a 99.7% difference between the two proportions. So I've taught you how to find outrageous percentages. You find the alpha of this one divided by 2. Then you find the confidence between two proportions. So difference between two proportions, confidence interval, is equal to P1 and it's P2 plus or minus Z, and just do P1 here, Q1 here, over N1 here, plus P2, Q2 over N2. So this happens when you're dealing with two samples. For instance, you have A, sample B. You have a small proportion here and a big population here. So here maybe we have 30 over 50. Here we have 20 over 50. So example A, 30 over 50, that is 60%. Meaning our P is 0.6. 20 over 50, that is 40%. Meaning our P2 is 0.4. Okay, find a 95% confidence interval. So at 95%, our Z is 1.96. Then our P1, since here is 60%, 0.6 times 0.4 over the big population of 50. Plus, our proportion here is what? 0.4, meaning the Q here is what? 0.6. Population here will be over 50. And you know what to do. The difference here is 0.2 plus minus 1.96. And here the answer you can get is 0.04. Continue the computation. So what this means is, in this question here, you have two proportions, two samples. Sample A will be what? 100 over 400. So that's P1 for the adults. The big population is, a big N is what? 400. Our small N is what? 100. So 100 over 400, meaning our P1 is 0.25. Meaning our Q1 is what? 0.75. Here 600 and 300, our P1 here must be what? 0.5, meaning the Q1 will be what? 0.5 as well. And here you find the alpha, not find the Z, construct a 99.7% confidence interval. So I'd be happy if you spend time looking at these examples. We'll look at these topics during the week. This is the introduction to our week's work. Unless there are any questions, please speak now or forever hold your peace.
Collins Fiambo,